So we'll go ahead and start off. I am Katrina Manigan. I am the Director of Buildings and Homes for Denver's Office of Climate Action, Sustainability, and Resiliency. Courtney, do you want to say hi?
Hi everyone, Courtney Anderson on CASR's Buildings and Homes team.
Great, let's go to our CPD staff from the city on the phone. Joshua Armstrong.
I'm Josh Armstrong, CPD, Mechanical and Plumbing Plans Review Examiner.
Thanks, Josh. Let's go through our stakeholders. Jenny, you're at the top of my screen.
Good afternoon, Jenny Gonzalez, International Brotherhood of Electrical Workers, Local Union 68.
Thank you, Jenny. Taylor?
Taylor Roberts with Group 14 Engineering Energy Consultant.
Great. Matt?
Good afternoon, Matt Jones, Milliner White. I've been intermittent at some of these meetings, but I appreciate being allowed to listen in. Thank you.
Thank you for being here. And Darren Ramirez?
Yeah, I'm Darren with RJA, mechanical engineer and principal here at RJA.
Thank you so much, Darren. And Sean, do you want to say hi?
Sure, everyone. Sean Denniston with New Buildings Institute, and we are technical advisors to the city through this process.
And I saw Danny Bonnet join. He's fiddling with his headphones, though. Can you hear us, Danny? Do you want to say hi? You're muted, so I'll go to Mark Jelinski and come back to Danny for an introduction.
Oh, hi. Good timing. Just joined Mark Jelinski. I'm a chief mechanical engineer at RMH Group, mechanical and fire protection engineer, signer.
Thank you, Mark. And I think we lost Danny, which is okay. He's another CPD, I believe, mechanical plumbing plan reviewer. Right, Josh? For when Danny joins again.
Yep, he and I work together.
Perfect. Okay. Let's dive in. So this is the fourth meeting of the Commercial Electrification Working Group. This group is working to prepare code amendments to go to the IECC Code Committee for consideration and a vote next month when they meet to consider all of the working group code proposals around what this group thinks is a reasonable first step for the Denver market on requiring electrification of new buildings. And of course, just to center all of our thinking, one of the things that this group was challenged with was making sure new buildings are leading by example and doing more than existing buildings, which are required to electrify under the Energized Denver ordinance upon equipment replacement when cost effective, starting in 2025. But of course, the code we adopt now will still, lots of buildings that start coming into operation in 2025 will be designed under the code we pass now. So it's important that we make sure new buildings are leading the way this code cycle and think about how to balance that with making sure this is something that's really an achievable, sensible first step in code for Denver. So we're going to talk about the water heating proposal first and review that, and then we'll go to the space heating proposal. We think we've incorporated everything that the group had asked for through all the meetings into both of these. But then, you've all been reviewing. There may be other little things we catch. I know you sent us one thing via email, Taylor, that I think was a good catch. So we'll get to that. And so with that, Sean, take it away to walk through the water heating proposal. And let's see if we can wrap this up as this is the right reasonable first step. It may not be, I'll just maybe flag again, it may not be something that like everyone absolutely loves, right? We know that this is hard to move to all electric new construction, but I'll remind you all, in case you weren't here for kind of the voting, we did a little bit of voting as we headed this direction and said, 5 is I love it, and 1 is it just can't happen, and 3 is like this is workable, but it's maybe not my total dream. And I think everybody was landing in 3s and 4s on the concept. So let's see if we got that right. Flag us if you're not there, sort of as we go. Okay, with that, Sean, go ahead.
All right. So as Katrina said, the fundamental of this proposal is to align it with Energize Denver as much as possible. So I did want to draw attention to, it does say fossil fuel and electric resistance, instantaneous and storage water heating equipment. So this does not cover gas boilers. They are similar to instantaneous gas water heaters, but they are a different kind of equipment. Oh,
Sorry, do we want to screen share?
oh yeah, that might be useful.
Thanks.
All right. Can everyone see that all right? All right. So yes, this doesn't apply to boilers at this time. The exceptions are based on the discussions that we've had so far. So of course, we don't want to cover resistance heating that is part of heat pump equipment, electric storage water heaters that are smaller than 20 gallons, because there's not a good non-electric resistance alternative to these water heaters, and they kind of make a lot of sense since they're typically serve small loads. This is the one that I think would appreciate the most feedback on, which is instantaneous electric water heaters located within 6 feet of the point of use. So we had talked about, it does make sense in certain applications to use an instantaneous electric water heater. It's a small load, it's point of use, but how you establish the threshold so that you're not ending up with a really big one and a really big electric resistance load. So instead of trying to size the water heater, we focused on the distance. And we'd really like feedback, one, on whether this is the right approach and whether that 6 feet is the right distance. The next exception is hot water storage tanks. Strictly speaking, this isn't necessary because a hot water storage tank does not fall under storage water heaters, but there could be some confusion. So we went ahead and included it just for greater clarity. This is when you have a tank that's just storing hot water that's heated by another source. And then we do also have an exception that aligns with Energize Denver for electric resistance when 100% of the annual service heating requirement is provided by an on-site renewable energy system. The wording of this is aligned with something that we already see in the code for high input water heating equipment. It's required to, when you have a high input boiler, basically, it's mostly boilers, they have to either have a higher efficiency or they have to have heat recovery or on-site renewable energy as the way to meet that requirement. So this is something that's familiar with the code, this X percentage of annual service water heating requirement. The next one is just the high temperature, which we aren't quite seeing heat pump water heaters broadly on the market yet. We're starting to see them emerge on the market, but not broadly for these high temperature water heating uses. And then this last one is electric resistance is allowed when 75% of the water heating load is met by a solar thermal system. So this, we don't want to prohibit solar thermal. It might not be real common, but it's a really great approach. And we chose 75% because once you put that together with the electric resistance, that's about the same efficiency as a heat pump water heater at its best operating conditions. So you see a little bit of equivalency there in the total efficiency. So we'd love feedback, particularly on that number 3.
Yeah, Darren, go ahead.
Yeah, I guess just kind of skimming through these. I mean, some of it's kind of little stuff. On the first one, I do worry about, even on larger central heat pump water heating systems, when we do start to see those, people are going to want to integrate electric heating either in a trim tank or for recirculation boosting. And so I wonder if that first one should be updated not to say integral into the heat pump equipment, but into the system or something of that nature, because you're still always going to have something even on a fancy large air source heat pump system. So that was one comment. I like the thing you brought up about the location of the water heater. I'm not fully sure that I'm really following it, though, about the 6 feet rule. And to me, it seems to be confusing because it's also sort of doesn't follow the similar use of like the efficient hot water piping systems section. And so I'd be curious to hear, Sean, just a little bit more about how you guys got there to that 6 feet thing. And then the other question too, I guess I just had comparing between, you have to make up 100% with solar when you're doing on-site renewable energy, but only 75 if you're doing solar thermal. Seems like those two aren't exactly conflict or the same. So that's my thoughts.
Sean, do you want to respond to each of those? And then I see Jenny, you had your hand up. We'll go to you next. Does that sound good? I think you're muted, Sean.
Thank you. For the electric resistance that might be integrated into a larger central heat pump water heating system, we do see them used sometimes for trim or swing tanks. Sometimes we see a different kind of heat pump water heater used for those. We'd need to be careful with the language to make sure that we're not just allowing a little heat pump water heater with a bunch of electric resistance. Right. That always becomes the challenge with built up integrated systems. So we would need to think about that. If we do want to have specific allowance for that, then we would need to work on that language. So the 6 feet is based on, actually it is based on the efficient water heating. I forget the name of it, but 6 feet is the farthest distance that a lavatory faucet can be from a source of hot water under the energy code. You have to use 1/4-inch pipe to get to 6 inches, but so that was just used as a starting point for the conversation. It's one of the reasons that we were hoping for the feedback on kind of what is that appropriate distance if we're thinking about an instantaneous water heater that's being used to serve, like a back-to-back lavatory or a kitchenette. What is that usable distance that is long enough that it's not creating a burden, but short enough that someone's not trying to create, kind of basically an electric boiler to serve a building. And then on the difference between the solar thermal and the on-site renewable, so that exception number 5 mirrors what's already in Energized Denver. Energized Denver doesn't really address solar thermal. So, it was kind of built up separately. And so I guess if there's a feeling like they need to correspond with each other, that's something that we can discuss.
Darren, maybe first, anything you want to respond to on that? I don't know if you have a specific suggestion on the first one in particular, and then we'll go to Jenny.
Yeah, no, I mean, Sean's points are all valid. I just, I think it has to be addressed in some way. I mean, central heat pump water systems are a stretch of any sort, and not allowing them to include any sort of electric resistance seems like a non-starter, probably, just so.
Okay.
But the 6 foot thing does, I mean, I see how you got there. It kind of makes sense, I guess my only question too is, again, where if 5 uses the definition for on-site renewable energy, like, doesn't that definition just basically say any kind of solar? So that's my concern, I guess.
Yeah, it does. And that was one of the things that was brought up earlier in the conversation, is that technically 5 includes 7. But there was a desire to have solar thermal called out specifically.
Got it. Okay.
Jenny, do you want to go ahead? I think you're muted. Jenny, you have to unmute if we're gonna.
Sorry, you think etiquette would be learned by now, right? So I was just gonna speak up about 5 and 7 being like under the same capsule of what you guys just spoke about. So I think that is addressed for me. And then being the electrician in the room, please keep in mind that you do have to follow your national electrical code for your buildings to pass inspection. Any electricity located within a source of water within 6 feet has to be GFCI protected. That doesn't make sense to do it on a water heater. So anything beyond 6 feet would be my recommendation to you. So you're not plugging into a GFCI and you're not requiring it at your breaker panel. Just, a little heads up there. put it any closer and you're gonna have either a breaker come into play or a GFCI outlet to handle that
Yeah.
requirement.
Would you recommend increasing it to a certain distance beyond 6?
I'm not too sure how that would play on the heating of the whole purpose of it. I would just say keep it out of that 6 feet range. So like 6 foot 1 inch, you're fine. You know what I mean?
Yeah.
Yeah, the tricky bit is that defeats the purpose of doing the InstaHot, and you'd have to recirculate it. So, yeah.
Yeah, that's not going to make any sense. You have to keep reset. Yeah. So put it without location of a GFCI being necessary. It's going to save a lot of headaches.
So allow them to choose to make it that close, but don't require it to be that close.
No, anything within 6 feet is required to be GFCI protected. Put it out of that 6 feet range and you won't have to add any protection on that actual load. So
See if oh, go ahead, Sean.
Oh, I was just going to say that if we require it to be within 6 feet, then we're effectively requiring it to be on a GFCI. But
according to your national electrical code, yes.
But
And
if we allow beyond 6 feet, then it becomes the designer's choice whether or not it ends up being on a GFCI.
There you go. Thank you. That's it. That's my point.
Okay, yeah, I think that's where good. I think that's where Jenny was going. That we make it the designer's choice. And if they want to do the GFCI so that they don't have to recirculate to where I think you were going, Darren, then that would be okay. If we just put it at like, I don't know, should we just put it at like 8 feet or something? Sean, do you have a recommendation for what we change it to?
I think thinking about real world application of how they're designed. And so, when we do have just a small water heater serving a couple of lavatories where it's bigger than that 20-gallon tank, then what is the normal distance for those water heaters from the farthest load in that application? I know some of the distances that might exist, but design trends vary from market to market. And so I'm curious if we have those trends in Denver.
I'll go to Taylor. You can see if he has comments on that or anything else.
I don't on that. So if someone wants to answer that question, they can, because mine's going to change the subject probably a little. So
does anyone want to chime in with an answer to the design distance question in Denver?
Yeah, I can do that. And that, first of all, it was mentioned earlier about the whole point of these things is to minimize recirc lines. So we're already obligated to be very close to the source of either a recirc line or the water heater itself, particularly in anything that's called a public lavatory. It's actually, if we're going to use any practical pipe size, like 1/2 inch, let's say, we're actually about, 6 inches, 18 inches, some amount of inches away is that requirement. So if we're using a instantaneous electric water heater for a public lavatory, it's going directly under the lavatory, period. That's where it's going. The other big application for these things is in a remote break room that's not close to a core plumbed area with hot water. And therefore, again, it's going under the cabinet of the break room sink. So now we deal with that all the time. Yes, we have to do a GFCI protected circuit, but that's better than all that recirc piping, and that's why it's done, and it's done quite often. I believe bottom line, I believe the 6 feet is within practicality. We could make it 10 feet in order to allow to get it away from GFCI range. And in a case like, for instance, that break room I mentioned, there's not a code requirement to be that close to the faucet. It's only in a public lavatory. So does that help?
That does. Is everyone okay if we went to 10? I think I saw you nodding, Jenny, like that was your preference.
And I would say that opens up some flexibility too, just to kind of get above, like you said, your standard office ceiling or whatever it is, right? But still be basically in the same zone.
Great.
And it takes that financial responsibility off of that GFCI addition on top of to what you're already trying to do.
Okay, that sounds good. I don't think we resolved Darren's other comment entirely. Is that the direction you're going, Taylor, to comment on the solar 5 and 7? Or do you want to go a new direction?
No, I was going to add my comment that I emailed you guys right
Yeah.
before.
I might have you wait just a second to see if we can wrap that one up. So does someone have a recommendation around how to handle that? Now remember, 5 is basically an exception saying you can put in all electric resistance if you have the on-site renewable energy. So I think it's a little bit of a different thing than 7, because that's just saying as long as 75% of it's solar, you can do some electric resistance. It just lets you have some electric resistance in the case of solar. But do folks really struggle with those? And does someone have a proposal of what we would change if we were to resolve that in some way? Okay, you can keep thinking on it. I can circle back on the question of 5 and 7, but we need to move to space heat relatively soon. Similarly, on the first one, Darren, would you have any language around like how to define a system in a way that doesn't create loopholes like Sean was worried about? Like, is there something about a backup? Or Sean, I don't know if you have thoughts, you know, a system where electric resistance is used for, you know, backup heating, below.
I would think it's similar to the way you're handling 5 and 7, just a percentage of annual consumption. Seems relatively straightforward, you know.
What if it were only for recirculation loop temperature maintenance? Do you think that would be enough?
That's certainly easier to justify. My concern with all these on the percentage numbers is, you know, if you want me to model out my domestic hot water consumption with any accuracy, it's pretty difficult, right? So
Right.
I like keeping it simple.
Okay, do you want to try typing some language like that in, Sean, so people can see it and think about it? And we'll go to Taylor. Go ahead, Taylor.
Oh, yeah, mine was just to be consistent with the electric heating one as well. We had done the electric resistance is okay if the building complies with C407. So my recommendation was just to do that here as well. I don't have any specific example off the top of my head that it's for like C407, but just to to have that flexibility if the building is meeting all the requirements of the energy code, and then allow that flexibility. I would say the one recent example that did make me a little nervous is just on a project in Boulder with heat pump water heaters. At the permit comments, we ran into issues with how specifically we were venting those, and they were venting into a corridor, which isn't really allowed under other code issues. So it's a whole deal, but essentially they ended up going resistance and adding more PV and still meeting the same requirements. So just allowing that flexibility, I think, is valid.
So Taylor, for space heating, we were thinking of a specific application, that the VAV with electric resistance reheat or heat, depending on how you want to phrase it. Is there a system like that for water heating that you're thinking of? I think if you just exempt C407, if the site energy path gets allowed, that's basically a free pass for all electric resistance in any modeled building, because the baseline is going to be a gas water heating system for most building types, and on site energy, electric resistance is going to fare pretty well.
Yeah, I mean, I think that's a good point, and this could open up the whole other can of worms of would you rather have a central boiler or individual electric, and where that goes. But yeah.
Although if we limited it only to the energy costs, that would control how much electric resistance you could put into the building.
Could be limited to energy cost or
target.
or your PEUI target.
Honestly, Sean, when I was thinking about it, is more like just non-typical buildings. Like if you just had, like I wasn't thinking multifamily, as much as just like, I don't know, like something with low water use, but they still would maybe do an electric resistant 100-gallon water heater, and it's just not much of the load of the whole building. Was honestly where I was thinking, but that is, it could be a major concern with C407 with site energy. Like I think you could get a multifamily with electric resistance to
It's
pass.
just what we're trying to avoid in part. Okay, let's think on that. Maybe I'll circle back to that topic while folks, and then I'll let others weigh in on it. But Mike Fulton, you're next on that topic or others, and we will need to move to space heat soon.
I just had a quick comment to follow up on Darren's comment of modeling the usage. So long time ago, I used to sell water to water heat pumps for industrial, commercial, like rec centers and hospitals. And so I bought a meter to test, to track how much hot water the facility was using. And I was shocked how little it is in so many applications. So I think the modeling part gets really difficult because, just based on my experience. So I just wanted to add that in.
Thanks. Are you okay with it staying there for just the solar thermal? I think that's the only place we have.
Yeah, this isn't
But
really.
that was just hard to figure out otherwise. We didn't want someone just doing some tiny solar thermal system and then putting all electric resistance in all the multifamily units in a building, right?
Yeah, I don't really have a comment on that.
Okay. Thank you. Mark Jelinski.
Yeah, hopefully a quick comment on the need for having additional resistance heat. And that is in a good practical solution for high temperature water. Really, I mean, anything over 140. You've got 180 in there. The reality of making 180-degree water is that if you do it with a heat pump water heater, it will be the resistance heat that will do the rest of the work. A good, efficient, practical way to do most of your water heating with a heat pump would be to have one tank that was all heat pump heated to like 120 or 140 at the most, and then boost it for the minimal amount of water being used at a dishwasher or in a sterilizing application in the medical application. So to cover both issues of how do we allow for some resistance heat to cover those trim tanks was used. That's what I'm really talking about, is getting it up to one temperature with heat pump and then the next temperature with electric resistance. So allow for that is my recommendation.
Do others agree with that? And Sean, do you have ideas on how to add it? Or thoughts on that?
Number 7 could be rewritten as basically as a boost water heater. I think one of the considerations is that this is often, we're not just talking about electric resistance that would be exempted on this. We are also talking about gas water heaters would be exempted for this, where loads and first hour recovery could be an issue for heat pump water heaters in some applications. I'll give an example local here to a brewery that, was using instantaneous gas water heaters as part of their brewery process because no other water heater, except for a boiler, had could supply the continuous hot water that they needed for that application. So if you had a booster tank backing up a heat pump water heater, it wouldn't have worked for them because the booster tank would have been undersized.
Don't undersize it. I mean, that's actually the perfect application of that. What it really highlights is You know, I don't like this at all. It's picking winners and losers. And one of the losers is going to be efficient generation of hot water for that brewery. The best way to do that was with a instantaneous water heater that took the coldest water possible, got 98% efficiency heating it. What this is requiring is, if it's not electric or heat pump, which is very difficult to meet, as you just mentioned, without a separate tank storing a lot of water for that surge at a higher temperature. It can be done, but it gets expensive. The most efficient way to do that is with a instantaneous water heater and not storing water.
Well, and this allows that. Number 7 would allow that brewery example.
But if they needed 175 degree water, 160 degree water.
Mm. So do you think that
And
180
really,
should be
pump,
dropped?
a market-ready heat pump, we can do it. We engineers can pick the cutting edge, most expensive CO2 heat pumps out there and make 180 degree water. But the commercial ready stuff pretty much tops out at 140, especially if you're thinking about the standard state A.O. Smith Green Root. Well,
Yeah, I would concur with that.
Yep.
So should this
Okay.
180 be dropped?
To 140.
Yes.
Well,
Okay.
it would need to be, we would need some buffer above 140, you know, even if it's just like 1 degree. Because 140 is what your standard storage does. But, you know, is it 150? Is that low enough? I think we're
Well,
excluding all the same equipment this way.
Part of the issue is with the refrigerant itself. So 410A, which is going away, but my understanding is that the replacement is similar. Basically, the refrigeration doesn't work above about 160 degrees, which then, like, that's the absolute working limit, which you need a safety below that. So theoretically, you know, or an operation 140 is what everybody does. So I would suggest you say 141 to meet your requirement.
Others agree?
It certainly seems a lot more achievable, yeah, than 180. So.
yeah, that's an improvement. Yep.
Okay. Circling back to Taylor's point, because I think we wrapped up most of the others. What do others think of allowing buildings that comply with the modeling path a pass on electric resistance?
I mean, it makes sense to me as a designer. You know, we're going to be having to kind of convince a lot of people to spend a lot of money on a lot of things to achieve this, and to at least then be able to say, and please just throw in a cheap little electric tank water heater for the thing you use twice a day or whatever it is, would be helpful. So.
Okay. Does anybody see that causing loopholes? I mean, if it sounds like everyone's thinking that would be used just by that, like, you know, small water, hot water usage in an unusual building type.
As long as the site energy path, if it passes, isn't allowed for it, then there's not a concern with a loophole. Energy cost discourages electric resistance, and the energy targets will discourage electric resistance for bigger loads, I think.
Right. Okay.
So would that just be a note, Sean, or, I mean, I don't know how you, exactly how you address that, but, yeah.
Oh, in terms of what has already passed?
Yeah,
You mean-
well, saying like comply with C407. Oh, does that address it right there, how you wrote it, Sean?
Yeah, that addresses it.
Oh,
It creates an
okay.
exception from these for those 2 modeling paths.
Gotcha, okay.
Okay. Final words, let's move to space heat. If not, I'll pause for a moment, but All right, let's move to space heat. I think this was really good. We were very close, so we made some final tweaks. Thank you all. Well, Sean will clean this up.
I think that cleans it up.
Okay. The XX is gone.
Let me bring up the other one. All right. Can everyone see that one all right?
Yes.
I'm seeing nodding heads. All right. So the first thing to cover here is that this does capture a change in a slight difference in approach. There was a concern about how space heating systems that are either desired to be backed up or required to be backed up could be handled in here, because if they have to be electric, that creates a very large backup requirement. So we are leveraging definitions of emergency power system and standby power system within this, and we'll get to that in just a little bit. Again, the purpose of this is to align it with the first round of requirements from Energize Denver, which have retrofit requirements for fossil fuel warm air furnaces and electric resistance heating equipment. Very similar structure, shall not be permitted. And then we have exceptions. And that first one is where we leverage those definitions. And that's where it has been demonstrated to the code official that the building is required to provide heating with an emergency backup system or standby power system. Then we have makeup air systems where energy recovery ventilation is prohibited by the International Mechanical Code. And there's a little bit of a nuance to that we can discuss if we need to. Electric resistance in buildings that comply with section C407, I should add. And this would allow that if you can just come up with an efficient design that uses electric resistance, then do it. Electric resistance is used for supplementary heat. And this is supplementary heat is heat that backs up a heat pump. We already have language that regulates that. And if you look here, we have made a slight modification to this to make it apply to any kind of supplementary heat and not just electric resistance heat. So you could use gas for your supplementary heat system under this. Up to 1.35 watts of electric resistant space heating per square foot of conditioned floor area. This allows two things. It allows for a low energy building that, like something that's built to the passive house standard, where the heating loads are so low, you can just do it with electric resistance. It's not a big load at that point. It also then allows for, if your primary heating system is something else, that you can use a little bit of electric resistance heating for boost and spot heating, stairways, maybe you just need a space to be a little bit warmer, things like that. And then again, we have the electric resistance heating elements integrated into heat pump equipment. I think this is pretty straightforward. I'll go ahead and talk about number 2 just briefly. Mark brought up that the mechanical code doesn't allow you to use energy recovery ventilation in certain exhaust streams, except for a certain kind of energy recovery ventilation. And so we've just simplified it. So rather getting into the permitted kinds of energy recovery ventilation and the non-permitted kinds of energy recovery ventilation, we've just provided a blanket exemption at this point to keep this simple and clear for users.
Okay. Any comments on this one?
I guess I have a kind of just fundamental question.
Yeah.
Not necessarily about the exceptions or anything. I guess I struggle with when I read this, I can't help but wonder if you're really just for a very large certain types of buildings, inadvertently just steering people to doing natural gas boilers. That's one of my concerns. You know, someone who wants zone control for a typical office, you say, great, I can't do this. I really don't want BRF because I'm not a person who's into proprietary things. Give me a boiler. And that's going to happen. It seems like you're opening the door to that a lot, is my first thought.
Is there a type of system that is covered under this that you think would be supplanted by central boiler? I think I know what the answer is, but I'm curious what you're thinking.
Is there a type of system?
Yeah, that would be prohibited by this that you think a central boiler would then step in to replace.
Well, I mean, we used the example of electric reheat or, you know, fan power VAVs or whatever it is. That's an obvious one, I think, but there's probably lots others too. I don't know.
Do you use those in buildings that follow the prescriptive path?
All the time, yeah.
Let's stay on that comment. What do others think of that? Is that a real risk? We had heard sort of in previous discussions of the working group that a lot of folks didn't think that was a big risk because boilers just don't go into the types of buildings that put in furnaces, but we don't want to put in a whole bunch more hard to electrify system types. Okay, we can keep thinking on that.
I think Mark has his.
Mark, yeah, I'd be
Yeah, but I
curious.
see Mark's hand up, so go ahead, Mark. I assume it's on a
Yeah,
different topic. You didn't speak
to
up
answer
back.
the question about is this indeed a common system, or what it's replacing, I guess. Yes, the terminal heat, any sort of terminal heat using electric resistance. We would be, and I understood in previous conversations that it's actually a feature, not a bug, that this allows us to use a gas-fired hydronic boiler to provide for zone control. So that's, I don't see a problem with that. And yes, it will force that. In the olden days, a rooftop unit with electric resistance at the perimeter was considered a cheap developer building. It's now that cheap developer, if he doesn't want to go through full VRF or the other more challenging systems, they'd probably be they'd rather use a hydronic hot water boiler system. And certainly for the mid and good level quality buildings, that's what we've been doing for mid and good level quality buildings is gas-fired hydronic heat at the terminals.
Yeah, and that's an interesting point, I would say, Mark, too. I guess the good thing also about if you do encourage people to go to a boiler system where maybe they would have used more of a package unit or something, when you're redoing this again in 10 years, hopefully the option there then to electrify that boiler plant also is the next phase of it. So maybe it is purposeful, but.
Boy, I personally think that if you're looking to do a water-to-water heat pump to replace a boiler, your COPs are just not going to be very efficient, and it's a bad place to start. Like, if the goal is to get gas out of a building, I think allowing a boiler in, you're setting yourself up for failure. The COPs just aren't there for water, air to water or water to water. So
yeah, with the temperatures, especially.
That's right.
Yeah.
With current technology, we consider the boilers the really hard to electrify systems. Do you have something you might propose, Darren, to resolve that particular application here? Because it sounds like it's something where and apologies because I am not the mechanical engineer, but it's the systems where you're getting a combination of the rooftop unit furnace with the boiler, where the electric resistance is used. It's part of the system in some buildings today, where we'd rather it wasn't part of the system. Because it's still appropriate in your mind to use electric resistance in that case? Is it actually preferable? Could that all be heat pumps? Talk me through what possible solutions might be.
Yeah, that's a great question. I mean, and it's like, which one are you choosing? Like you said, and if we're comparing, if the goal is electrification above efficiency, that's one thing. I don't know. I don't know what the great outcome is, and I'm not saying it's a bad thing necessarily either. It's intriguing to me because I would probably look at these sort of medium-sized buildings that often use sort of gas-fired packaged equipment. Think of like a mechanical people, like a 50-ton kind of, package unit or something. That to me is an easy swap out to a boiler system, right? I don't know.
So one of the things that Taylor and we've done a few modeling of this is having a kind of your conventional developer building that Mark was talking about, only you have a heat pump in your main air handler with energy recovery. And the heat pump, you set it up to supply 65 degrees in the winter, which then means you're only heating from 65 up to whatever heat you need instead of 55 in a conventional system. And that way you're getting a 2 or 3 COP instead of a 1. And I guess that's my biggest problem with exception 5 is you're saying electric resistance heat, you only get to do 1.35. But if I was to put a heat pump into the space, I could do 10, use 10 watts per square foot. There's no kind of efficiency offset there. So I get what you're saying there, Sean, that you have to model the building, but the problem is a lot of buildings don't get modeled and they just go the prescriptive path. So you're just limiting, in number 5, you're limiting those prescriptive paths and really kind of picking a winner in terms of a system.
Right. Yeah, I mean, to me, I would say number 5. I get the intent, but the number is so small that I get 2 heaters in a 10,000 square foot building, So
I mean,
not
just the
particularly
ventilation
useful.
load.
Yeah.
Just the ventilation load alone, is pretty close to that for one person in an office building. So, or in an office.
I want to go to you next, Jenny, because you'd had your hand up. Unless you're good. Okay. But I want to ask, is it just a change to number 5 that could solve this challenge to allow electric resistance for some of these terminal systems? If I got that terminology correct. Where at least this is our first step into electrification. We don't want to drive up operating costs by titling a lot of buildings with all electric resistance, but is there an amount that doesn't do that seems appropriate, because the heat pump does most of it, is what I hear you all searching for? Does someone have something they want to propose that might get there?
Well, could I ask this, because I get you don't want to drive up costs, but why? I guess that's a great anecdote, but you could either require modeling so that people understood their costs, or give an EUI target or something like that to kind of overcome that, instead of the problem is you got this prescriptive that most people, I would think, Darren, correct me if I'm wrong, but most of the buildings probably go prescriptive. So you're not going to model them, and then you're going to end up with systems that might not be the best for the city and the.
This would allow all the systems that you're talking about, just not in the prescriptive path. They would have to be modeled.
Right, which then drives the cost up.
And
so that's my struggle.
Maybe that's a good question. Is Danny still on? I don't know if Danny or Chuck were on today, but yeah, I mean, I would wager if you just looked at
I'm here.
Chuck
is out, but I'm here.
all the square footage in Denver of just buildings that get built, how much of it goes prescriptive path. If you had to make a wild guess, Danny, what would you think that is?
I would say most of the existing tenant finishes are prescriptive. New buildings are modeled. So we have probably a 60% prescriptive path approach on all projects that we see.
But we're specifically here talking about new construction buildings entirely.
Mhm.
Right?
Right. So on the newer buildings, most of them are being modeled, but anything else other than that, pretty much prescriptive.
But this only covers new buildings. And so Danny, you're saying new buildings are all modeled, even smaller ones that are putting in furnaces?
Not smaller ones, I would say, office buildings that are 3 stories or less are probably going prescriptive. Even 4 stories or less are mainly prescriptive.
Yeah.
Katrina, it lines up, I would bet, very well with 2 items, GBO requirements and Excel's EDA qualification, right? So 25, 50,000 square foot, if you're below that, prescriptive. If you're above, if you're in between 25 to 50, it's probably I don't know, it's maybe iffy, but I would say over 50 definitely seems like, right, most are going performance. 50,000 square feet.
Yeah, that feels right.
Yeah, that sounds right. There are other reasons to go model other than code compliance.
Yeah, I mean, on our buildings above 50, it's not even a discussion usually of if we're going to do it, right? But that's just the assumption. So.
Can I go back to the question then about number 5? Because I do think the nature of this proposal is that it's the easy to electrify equipment type, which is the furnaces, which tend to go in the smaller buildings, right? So some of them at least will go prescriptive. Is there something that we could do to adjust number 5? Because that's so that it's not sort of aiming at like a passive house level of efficiency, but something that's like a good first step for Denver, where some, reasonable amount of electric resistance is allowed.
I mean, I ran some numbers. I sent them to you. Taylor would probably be better, or Darren, but you're somewhere 9 to 5 watts per square foot, in a lot of applications.
I mean, that was kind of my thought too, Mike. I mean, I think if you had a good building envelope, right, meaning new modern prescriptive standards, a skin load on the order of 15 BTUs a square foot, so 5 watts a square foot is totally, it's not crazy at all. It often might be higher than that. And that's really just skin load like you might use for terminal systems, not to mention a little bit of ventilation lift. So somewhere north of that 5 watts makes a lot of sense to me, but I don't know if that defeats the purpose also.
Well, I think that gets to one of the key questions then. Besides VAV with terminal, are there any other system types where this would really be useful?
All the perimeter heating type systems, right? So maybe not just VAV, but maybe it's radiant perimeter or even baseboard for that matter, things like that, just traditional type systems. Yeah.
2 pipe fan coils. Again, I don't know if that's what is wanted. And Sean, sorry, just to clarify, I think we've gone over this again. So like an existing building that was replacing HVAC, would they be required to follow this or not?
No, this isn't new construction at all. It's new buildings specifically. So this would only be for completely new buildings.
Equipment replacement will all follow the Energized Denver code language, which we'll be sharing. You all have seen the Energized Denver ordinance, but we'll have the actual code language out for a bunch of public input in July. Okay, Jenny, I want you to weigh in. I heard a move for maybe 5 watts per square foot. So think about that also while Jenny weighs in on sort of how does that balance, operating costs with not putting in a lot of boiler systems that are hard to electrify. Go ahead, Jenny.
Because these are new buildings, and I would hope that us setting rules and standards would have some say into how it is designed, which would alleviate some of our stress. However, I am more asking a curious question, and it doesn't have to be answered to me at this time, but I gotta leave. I'm sorry, I got a 4 o'clock. What is this doing to the size of service on these new buildings? I mean, and again, that is just a curiosity question. You're going from one centralized location providing electricity to a broiler system to now trying to electrify numerous different objects within your building. Is this making the service actually smaller and more efficient? Are you going to, is it a bigger service size at this time? And again, that is just my curiosity question. Again, that is just incoming service, your panel size. Just curious in my brain. You don't have to answer me that now. Katrina, I do have to leave. I apologize. If there's anything else I can do for you, and please give me more schedules to attend your meetings, okay?
Thank you so much, Jenny.
Thank you. Everybody
Jenny,
good night.
I think a quick answer, at least to your question, would be that there are probably some buildings that it might increase the service size depending on their design decisions. But in general, for commercial buildings, I would imagine that the service sizes would generally be fairly consistent to what they are now, just because those buildings already have air conditioning.
Thanks, Sean. Okay, so we took a lot of time on that point. So I'm hopeful that people don't have a lot of other things on their mind, but I open the question for other things on your mind, and I may ask you all to stay over for those who can, should there be lots of other things on your mind. I would love to wrap up in 2 minutes. Are there other things? Feel free to drop them in the chat, chime in, raise your hand.
I have one other comment on number 6. So I'm not sure if you change 5, I'm not sure you need 6 anymore. The problem I had with 6 is that you're saying it's okay to put electric heat into a heat pump, but not into a VAV, like a fan powered VAV, which doesn't really make sense to me. But so I think you could get rid of 6 if you up 5 to the 5 watts per square foot, and you need to add the per square foot there. Does that make sense?
And
Yeah.
doesn't 4 kind of address that also?
Okay.
So 4 kind of does. For number 6, 4 would kind of do it. I know that AHRI would not be happy about that, because then that would mean that 4 would regulate the equipment internals for integrated resistance. 5, it probably would cover it as well, except for, I think in most cases, you wouldn't know what the electric resistance for the heat pump was, because the efficiency rating for heat pump that has integrated electric resistance, that electric resistance performance is just captured within the HSPF or whatever other applicable energy rating. 6 may not be strictly necessary, but this makes it clear that the requirement isn't talking about the electric resistance that is part of a piece of heat pump equipment. So you just don't have to worry about it, and you don't have to be confused about it.
Are people okay with it staying?
I don't, I think the issue that I think that needs to be clarified, Sean, you just kind of confused me, so it needs to be clarified, is when you're talking this 5 watts, are we talking just at the perimeter, or are we talking integral to a rooftop and the perimeter? Because I think you need to separate that. I could see problems both ways. So if you're talking if you're talking about how many watts a heat pump would use, like a heat pump water heater, then I think you're going to have to up your values here, because the ventilation air is going to be all over the board. If it's 10% outside air, it's not going to be much. If it's 50 for whatever reason, you can't get to that 5 watts.
So the way that it's phrased right now, you could really think of it as a whole building budget. So you have your conditioned floor area, you multiply that by 5 watts. That's how much electric resistance you can use in your building, however you want to use it.
Yeah, I don't think that's going to be enough then. Because the numbers I ran were just ventilation air from, say, 55 degrees to 70. And, you know, you're anywhere from 9. The low value I've got here is 4. You know, I don't do this all day. These are, but still, I think it's in that right. Maybe Darren and Mark, you could chime in.
Well, I guess that does raise the question, do we want to allow electric resistance to raise from 55 to 70? Or if you're going to design a system that uses electric resistance, do you have to get there? You know,
Have to get to 65. Yeah,
Yeah.
I mean, the goal is to get to 65 to take the load off of the electric resistance. So, you know, you could say something like that. Unfortunately, right now, the industry can't always get there at -10. So you're going to have some sort of supplemental electric heat. So, you know, and I think my big picture is, you know, I get wanting to get rid of warm air furnaces, but also adding in electric resistance, it's like 2 big hills to climb.
So in the circumstance that you're talking
Oh.
about, 5 would give you a certain amount of electric resistance just for your heat up in your terminal boxes. If you had additional,
skin and ventilation was what I calculated.
If you had additional electric resistance that you needed for low temperature operation, then I think, where is it? 4 covers it, because at that point you can consider it supplementary heat.
Okay.
Yeah, and I think that's part of the confusion that Mike was saying. I mean, maybe it is clear, but to me at first read, it's not obvious if that 5 watts is a whole building budget, like you said, or if I can put supplementary heat on top of that. Because yeah, 5 watts a foot doesn't get you very far, you know, if you're also backing up the main air handling system.
Here's the way I read this, is that there's several additive, and we just need to, this is what would make it worthwhile. We just need to make sure that the language comes out that way. There's 3 additive things that can be used here for supplemental heat or resistance heat. First of all, any resistance heat to make up for when the unit starts to run out of capacity. So first of all, that covers the the ventilation load problem. As soon as the unit starts running out of capacity, that's exception number 1 under heat pump supplemental reheat, then the resistance heat can indeed take over. Resistance heat, integrated into the heat pump equipment. The way that's written right now, there's no limit to that, so I can put as much electric resistance heat in that rooftop unit to cover, the building heat and the ventilation heat. And then the 5 watts, yes, it does need to be made to be 5 watts per square foot, but 5 watts per square foot of resistance heat of conditioned floor area in the building gives for a sufficient amount of perimeter heat only if we've taken care of the ventilation heat elsewhere, ventilation loads elsewhere. And a good design, what I would do when we're paid to do a good design, is what Mike's been talking about, plus heat recovery, right? Reduce the ventilation load in the first place with things like heat recovery, and then deal with the raised temperature that heat recovery gets you. You can probably do it with heat pump from that point. And if not, the other exceptions that you've already got there, get us the rest of the way. So it is indeed possible. The other type of system that you were asking about, the 2-pipe, anything with perimeter heat, 5 watts a square foot of distributed baseboard or electric panels. Again, it's probably enough just for a good load, a good perimeter load, and force us to make the perimeter and envelope that much better if we're going to do it this way.
Yeah.
Now that we're at 5 watts per square foot for the whole dang building, I'm challenged, but I can do it.
That was what I was thinking. I mean, to me, it's not 5 watts is not generous, just to be clear. You know, it's definitely doable, but you have an aggressive reset strategy to get up to 65. You have good building
Yep.
envelope. There's a lot of things required to get there.
And I think that's
Yeah.
exactly what we want. We want
Yep.
them to design a
Right.
good system that gets you
That-
there.
That sounds like the right balance on that. I agree. And I was just wondering, like, this still doesn't preclude putting in the boiler. We just don't want to drive everyone there, right? I think that we have to be somewhat practical in all of this, and like, I don't, boilers are going to be hard to electrify, but they're also, there just might be, like, generally maybe service system size doesn't need to go up, but like in some buildings, maybe it would for some reason, right? To cover those coldest days. And so there just might be a reason that some people want to keep boilers. So this hopefully gives them good flexibility if they have good design, but doesn't preclude that. Does that make sense?
Yeah, I just have one to piggyback off of what Mark said. I would add to 5 that this does not include ventilation somehow.
I think it's getting a little clunky, Mike, actually. Since you've already got it, resistance heat elements integrated into heat pump equipment, that's 98% of where outside air is coming in.
Okay, so then clarify that it's just, somehow you need to clarify it as perimeter heat. Just to
Why?
not confuse it, because otherwise, you could read it that it's the main unit and the space.
Right. I think the way that Sean just typed that in is what I would expect to see.
There you go.
Yeah.
Okay, that works for me.
All right.
Okay.
It doesn't change the intent. It's maybe just a little bit clearer for users.
That's what I was trying
Good
to get
one.
at.
Good observation, Mike.
Okay. Thank you all for staying on just a couple extra minutes. Maybe I'll just do a quick gut check. How many are you still just going to put boilers in for a lot of those terminal systems? Or does this give people the push to do the good design in a lot of cases?
Well, I mean, first of all, I'm not sure about the premise there, but since it allows for hydronic boiler systems, it certainly allows for the right kind of mix of buildings. You've always stated that this first go around is trying to maintain a path of gas. It does that. I also concur that we should push the next code cycle. But
Yeah.
this code cycle, it's doing what you promised at the stakeholder meetings. Yes.
Yep. Okay.
I think, Katrina, that like you said, yeah, the tall buildings are still going to want to go boiler probably, but this does provide a path where those sort of smaller developer-driven projects have at least an economically feasible option to do electric, and they're not kind of pinned into having to do something else. So I think it's.
Well, I just have one. You guys are more modelers than I, but does this allow you to do electric VAV in a prescriptive path? Or do you still have to model?
It would allow it as long as you can get your terminals in at under that 5 watts.
Okay.
Yep.
I'm good with that then.
And you could go above the 5 watts if you want to model.
Yeah.
So if for some reason you need a little bit more capacity, but it's just not going to run as often,
Yep.
then the modeling would allow you a way to do that.
I think it's a good
Okay.
step.
I do too.
Thank you all. I didn't
Thanks
see
for your
anything
time
else in
again.
the chat, so I think I'm going to assume that there aren't other issues with this, but I'll pause for a moment. Danger of then having to hold you longer. This is the last meeting. All right, there was less to tweak on this one, but one thing that took quite a bit of time to sort out. Thank you all so much. Could I, since we've gone 10 minutes over, could I take just 1 minute on each of these? Because I'm actually just curious, and I wish we still had everyone, but we could even ask them afterwards. I'm curious if we could do a quick, that 1 to 5. How are you actually feeling about this as like the right first step? Because we got a lot of 3s last time. So the people that are still here, could we start with space heat since we're on it? Just type in the chat 1 to 5, 5, you love it and you think that Denver should pass it tomorrow and it's perfect, like as a first step on electrification, you think we're ready for it. 3 is like you're okay with it. 1 is you absolutely hate it. Quick space heat in the chat. How are we doing? So my sense is people like this more than they liked it a meeting or 2 ago, and it was still getting refined.
Not
Nobody-
everybody at once.
I was gonna say nobody wants to put anything in the chat. I can also just let you go because I've kept you over. But my sense was we're doing better.
Yeah, I guess my only thought, since boilers are an option, is 5 going to inadvertently drive people towards boilers? Like, I get the cost part, but your goal is to electrify and get gas out of buildings. You see what I'm saying?
It's the same question I tried to ask a minute ago, but perhaps worded more gracefully, I think.
I
I
doubt
think
that.
I heard that, but go ahead. If others want to chime in again, I think I heard that, yeah, some people will put boilers in, but they probably already were today. It's those higher end developers. But they have an option to do a good all electric piece, and that's just as the first step. And
Well, I guess my question,
we'll see.
my question there is, are you trying to get perfect and it's really the enemy of good? Or if you're going to drive it towards people doing boilers, developers aren't going to care. They're just going to do a boiler to save a buck if they have to over insulate the skin or something like that.
We're already pretty far from perfect.
What's that?
We're already pretty far from perfect.
Right.
All right. We can think on that question more. I've held you over. People might not want to vote again, which is totally fine. I think we'll sort of present the general sentiment that, not folks, this is a big push, but not necessarily everybody's dream. But it's a sort of feasible first step is sort of where I think the group had been telling us this was going. I think we've gotten the details right to go that direction. Any final words that people want to add just on any comments, just even on like what was the thoughts about this process? Did you like how the working group ran? If you have anything you want to share, if not, feel free to hop off. We would love any feedback or thoughts. Just was this useful? Was this good? Also, did you like going through this process? Have we gotten to, a place that you think is good to recommend to the committee? And if any just reflections would be welcome.
Yeah, I would say you pulled together a pretty good group of people, so I thought it was worthwhile.
Yeah, good stakeholders. Good job. Thanks, guys.
Thank you all for being here because we couldn't do it without you. And we're letting everyone go now. They're gone. They're hopping off, which is great. Okay.
Thank you, everyone.
Thank you all so much. Bye.
Thanks, everyone.